The broadcast is now starting. All attendees are in listen-only mode.
Hello and good afternoon, everyone. My name is Anna Zylik. I am with ICF, and we are the vendor working on behalf of the sponsors of Energize Connecticut to bring these passive house and all electric homes trainings to all of you. So thanks for joining us today. These trainings are at no cost thanks to the sponsors of Energize Connecticut and are part of a partnership with Connecticut Passive House. Today's training will be recorded and will be available online afterwards. A quick reminder that as part of this training and workforce development initiative, we are offering a 75% cost reimbursement for individuals pursuing either Phius or PHI professional accreditation. So this includes the cost of the trainings and the exam, and once you become certified, we work with you to process the 75% cost reimbursement. So if you have any questions about that process, please don't hesitate to contact us. And with that, I'll pass it over to Keegan, who is also with ICF, to talk about the Passive House and All Electric Homes building incentives.
Yeah, thanks, Anna. And hi, everyone. Thanks for joining us today. We're excited for today's webinar. So in addition to the no-cost educational training series and the professional accreditation reimbursements, sponsors of Energize Connecticut also offer robust incentives for builders and developers who choose to go all electric with their residential buildings or pursue passive house certification in their residential multifamily projects with 5 units or more. The passive house incentive design for Energize Connecticut, Mike, if you want to go to the next one, is shown here on the slide. It includes pre-construction incentives for things like feasibility studies and energy modeling to help you determine if your project can meet passive house standards, and post-construction incentives for full passive house certification through either PHI or Phius. Mike, next slide. The all-electric incentive is for both single family and multifamily buildings. It offers two levels of eligibility with specific design and performance requirements associated for each, and has incentive amounts ranging from $1,500 for multifamily units to $1,500 per unit for multifamily and $10,000 for single family homes. Ultimately, our goal is for everyone involved in the construction of residential buildings in the state of Connecticut to be aware of these incentives. So if you are interested in learning more, please visit our website or contact us directly after today's presentation. And as for questions during today's session, you can use the chat function on your control panel there on the GoToMeeting application throughout, and we will address the questions as they come in. So with that, I will turn it over to today's presenter, Michael O'Donnell from Stephen Winters Associates. Mike, take it away.
Great. Thanks, Keegan and Anna, for the intros and background. So today's presentation is going to be on compartmentalization air sealing with a focus on masonry and steel stud type of projects. And just a little bit about Stephen Winter and myself. I'm currently working out of their New York office, focusing on passive house projects, specifically the field side, so site inspections, testing, field implementation. And about our company, we have offices in New York, DC, Connecticut, and Boston, and a range of various energy services. So to start off with some of the basics, why air seal? I think some of these might be new to some people or maybe repeats, but we'll kind of just go through them. So I think first and foremost, most people think of air sealing is to save energy. And it kind of makes sense, right? By sealing up all your gaps and cracks and holes in your building envelope, you're helping keep your heated air inside, or in the summertime, keeping the AC in. So that's a pretty straightforward, I think, a common sense thing that most people can understand. And, this is an image of when you're running a blower door test and you can see the cold spots identified there under a door, right? So that's maybe a door to the outside that doesn't have any bottom sweep or weather stripping. So pretty, I think, intuitive, right? We're sealing up our buildings to keep the heated and cooled air that we've paid for inside as long as we can. Moving into multifamily, so it also compartmentalizing also helps to overcome the stack effect. So stack effect is essentially your building acting as a chimney in the wintertime in this example. So the lower floors are actually having infiltration while the upper floors are having exfiltration. So if you're living on a lower floor, you might notice some drafts around windows or outlets, or maybe imperfections in the drywall to ceiling and floor joints, and you'll actually feel air sort of coming in. And then at the top of the building, it's sort of the opposite, right? So we have the air that's going out. So it may not be a direct, like, hey, cold air is blowing on me, but you'll definitely have some comfort issues if now your heat has pathways to move out of the building. And so by compartmentalizing, you're essentially knocking down the stack effect by making each individual unit its own little air sealed box. It's not going to be 100% airtight, but with the allowable limits, it is significantly improving the air leakage rate of each apartment. And again, when you're stepping back and looking at the whole building, it is sort of reducing that overall impact of the stack effect. So this is a kind of a classic image. It's a building where you can see there's a tarp on the outside, and the lower part of the building, the tarp is getting sucked in, and the upper part of the building is being sort of blown out. So this is the stack effect in action, so to speak. And somewhere in the middle is what we call a neutral pressure plane. And this is kind of always changing, whether based on temperature differences, the wind effects, and mechanical effects within the building. But it's a sort of known phenomenon. And again, air sealing helps to reduce this. Another, I think, pretty interesting point about air sealing is reducing moisture drive and how much moisture is getting into building assemblies. So on the left, if you have just a 4x8 sheet of drywall, over the course of a heating season, it said that only 1/3 of a quart of water would actually diffuse and go directly through the material. Whereas if you had that same sheet of drywall with a 1-inch square hole, you're allowing, I think it's about 100 times as much water vapor through. So you can see that the vapor is like hitching a ride on the air, right, and getting through openings and gaps and cracks, which can be problematic, especially in wood-framed construction. So it's another thing to think about when we're asking why are we going through these extra efforts to get these apartments air sealed. Some additional benefits, controlling sound and smell. So I think sound is fairly straightforward, but if you have a direct line of sight or opening between two spaces, you're obviously going to hear noise, right? And if you ever lived in a multifamily apartment building or visited someone in a multifamily, it kind of depends on construction quality, right? Did they air seal anything? Do they have sound attenuation bats, or do you hear everything that your neighbor is doing above you or to your side? So it's another sort of additional benefit of air sealing, compartmentalization air sealing, is that you're helping reduce the sound transmission between adjacent units. And along those same lines, it's also smell transfers, right? So if your neighbor is cooking up a storm, you've probably, smelled that. Whether that's good or bad is to be seen, but the additional benefit there is you're, by having each box.
Sorry, Mike, I accidentally ended your screen share. If you want to go ahead and reshare that.
Yeah, I got some weird pop-ups there.
There you go. Sorry about that.
You can see it?
Yep.
Okay, cool. So yeah, just finishing up there on the smell aspect of it, right? So if you have your apartment well air sealed and your ventilation system is working properly, right, then the ventilation should be handling the majority and getting those smells out of the apartment and also keeping them from transferring to your neighbors. We do have a question. Does compartmentalization require in multifamily projects only, or does it apply to other types of buildings? So I think from a fire aspect, it can apply to pretty much any type of building, right? Whether it's educational, you have classrooms, hospitals, obviously, but the focus for today really is multifamily, and that's where a lot of the programs are either pushing incentives or requiring the compartmentalization to be implemented, but it kind of can apply to any project, depending on what the layout is. If it's a big open office space, there's really not much to compartmentalize. It's a, big open floor plan. But if you have, all little offices, or you have, again, classrooms or isolated spaces, I think all of these same concepts would apply. So leading into that, it overlaps a lot with fire stopping and smoke control. So again, if you're making your little box, quote, airtight or sealed, it's going to reduce the spread of a fire and hopefully unlikely event that a fire breaks out in your apartment. So you can see on the left, we have some pipes going through the floor, and those are all sealed with fire stop sealant, which is, priority for a fire code, but it also is sort of directly related to compartmentalization, air sealing for those, all the other benefits that we're talking about. And then on the right, you can see some fire stopping being done at the top of the wall and some wires going through the wall. So there's a pretty, I think, heavy overlap between fire stopping and air sealing for compartmentalization for energy and the other benefits. Occupant comfort. So this picture here is of a PTAC, or package terminal air conditioner. You've probably seen them if you've stayed in a hotel or visited someone in New York City. They're kind of everywhere. A lot of times, though, these are fairly leaky, so to speak, from an air tightness perspective. And, you might get cool drafts or uncomfortable, cold spots, especially near around these units. And so by, again, air sealing, you're going back to that initial one of you're helping to save energy, but you're also reducing those areas of path of least resistance for heat to be leaving your apartment in the heating season. The manufacturers of these PTACs actually are improving the air tightness. We're working on a couple projects with some manufacturers of trying to make these a little bit more airtight, and they are getting there, which is a good sign. But most of these PTACs that are out in existence, from 80s, 90s, they are kind of leaky and it can be uncomfortable. So it's an example of, if we're properly air sealing apartments, you don't have these cold spots or areas where the heat can easily escape. Pest migration. So this is, I think, true anywhere you live, but maybe, I don't want to say more so in the city, but I think you have a variety of critters that might visit you if you live in a dense multifamily building. So by air sealing, you're essentially cutting off, right, any sort of entry points or pathways for whatever, furry friends want to come visit you, or roaches, all that fun stuff. So again, by sealing all these holes and really not allowing these entry points, it does actually help a lot with pest migration, whether, you know, ants, mice, whatever you have. So it's another sort of co-benefit of air sealing an apartment. And we also have various codes and certifications. So under the energy code, you know, you more or less need to do it for single family homes, and testing is more or less required depending, you know, your jurisdiction and what code you're under. And then for other programs, Passive House US, they require compartmentalization, air sealing, and testing, along with Energy Star, Lead for Home. So it may also be a program driver or an incentive program as well that's driving air sealing and testing of those apartments to make sure they're actually meeting the rates. So how and where does air leakage occur? You basically need two things: an opening, so that can be cracks, small holes, large holes, or even permeable materials, and a driving force, so wind effect, stack effect, or mechanicals. And essentially, when we talk about it in a little bit, when you get to testing the apartment, right, you're sort of exaggerating that driving force. You have your blower door fan, and you're moving air through the apartment to get, you know, see what the leakage rate is out of sort of an exaggerated pressure. But all your cracks, holes, and materials that may not be airtight are going to come out and show themselves in that test. So that's something to keep in mind, is that a blower door test is a little bit exaggerated of maybe what the apartment would normally see, but it's a way to standardize how we're finding these air leaks and quantifying them in a way that sort of equal among projects. So where does air leakage occur? Essentially everywhere. So we have the bottom of the wall, we have the middle of the wall, maybe I have a inline duct exhaust that's going to the outside, top of the wall, at the entry door, closets, intersection with another unit. So there's a lot of areas to be thinking about, but it sort of helps to, you know, think about it in a systematic way, which we'll go through in a bit, so it just doesn't seem too overwhelming, right? If you just look at this, you say, oh my gosh, look at all these circles and areas we have to focus on, and you know, it kind of can be a lot, but it doesn't necessarily have to be if you start breaking it down and thinking about it in a sort of logical approach and way. So how can we control leakage and provide sufficient air sealing? So again, we'll start a little bit with some bigger concepts, but if you have a detached house, right, you have 100% ambient exposure. So that's your floor, your floor walls, and your ceiling are exposed to outside. Whereas in an apartment that needs to be compartmentalized, you really only have 16% in this example to the outside, but the other sides, the other 5 sides of your box still do matter, right? So it's not necessarily energy loss, but it's for all of those other reasons, right? So if you're leaky to your neighbor, you're going to have probably noise issues, maybe smell issues. The critters can get in. So in this exercise or this thought process, essentially all leakage, air leakage matters when you're trying to seal and compartmentalize your apartment units. And so there's a couple things about design sort of thrown throughout this presentation. And, you know, some of it's within control of the architect and designer, some of it maybe isn't, depending on how unit layouts and things like that work out. But this is just showing if you are able to minimize the enclosure area, you have less surface area, right, that can leak. So it's not to say, hey, we should be sort of cramming in all these very tiny, you know, small apartments, but it's just a sort of thought exercise to go through during the design. And it also sort of plays into one of the other slides, is just trying to make the geometry a little bit simpler. And that makes the approach in air sealing simpler as well. So this is an example of that, right? On the left, we have a fairly complex apartment. We're calculating to be 18 corners. So each of those right now is now a change in plane, and maybe it's a little bit tricky of how we get to do our air sealing at all of those weird jogs and junctures and corners. Whereas the example on the right, it's a very nice simple box, which, you might not have it that way, but some apartments are laid out that way. So it's, very efficient in the design and layout. And now you have sort of a simpler, idea. We just have a box. We are going to attack the corners first, which we'll get into. And it's a little bit easier to manage. So this, again, you can't always be fully influenced during the design phase, but it's something to try to keep in mind if you're going to sort of help the project team have an easier go at it from the beginning of the project. And so with that, sort of knowing the priorities, and what we mean by that is really on the image on the left there is a key priority, right, is the exterior facade of the building. So if that's leaky, you're going to have other problems, right? You're going to have water issues and just maybe massive heat loss if things aren't air sealed properly, and rot and decay. So that's obviously the first and foremost, I would say, focus is the exterior air sealing, getting the building weather tight and airtight. And, there's various approaches to do that. So that's, I think, in anyone's mind, the most important. And then the second step of it, right, is the other sides of the apartment or the box, so to speak, and how we're dealing with those and air sealing those. So it's this sort of two-edged approach. Yes, we want to obviously do the exterior, in a way that we don't get leaks or other bigger construction issues, and then really start focusing on the remaining aspects of the apartment to get that airtight. So these are just some examples of, typical approaches that we would see on mid to more high-rise type of projects. They're oftentimes using either a liquid applied air barrier. So the image on the left, you can see that the window rough opening has been wrapped with the blue. That's like a sort of a flashing sealant. The yellow is a roll-on liquid applied air barrier. Usually have to do 2 or 3 coats depending on how thick you need to get it from the manufacturer's data sheet. They have their various bolts there, and then it's going to have clips and a rain screen finish. And they have their window that's roughed in there, but the caulking isn't done yet, but I'll just get back rod and caulking. The middle one is similar, but a little bit different. It's exterior insulation or ephes approach. So you can see on the left side of the image, it's all just raw sort of dense glass that hasn't been coated yet. The middle, you can see that they've rolled on the majority of the blue. In this case, it happens to be blue, liquid applied air barrier. They're detailing the slab edges with the manufacturer's recommended mesh and additional products there. And then on the right, you can just kind of make out the edges of the insulation boards and the finish coat. So it's a similar idea. It's a liquid applied system, but again, different manufacturer, different materials. Obviously a little bit different with the ephes finish versus a bracket system, but in concept, sort of a similar idea that we're really sealing well from the outside with a liquid applied air barrier. And then the image on the right, Another approach could be a sheet membrane, so that's a peel and stick. And you would use a primer that comes with that from the manufacturer. So you would prime the dense glass and then apply this, and you would have to usually roll it with a roller to get the adhesion that's necessary and deal with the openings of the windows either with that or fluid applied. You know, a lot of these components from the same manufacturer systems are compatible, so you can use sort of an array of products from the same manufacturer to achieve that continuous exterior sealing. And so we've kind of thought through the outside of the building, and I think the next sort of good thought process is to think like water. So what we mean by that is imagine you take your apartment, which can be thought of as a six-sided box, right? Like this container here, and you dumped it in the ocean, right? You threw it in a bucket of water. Where would the water come in to that unit, right? And essentially air is going to do the same thing. So it's just a way to think about it and visualize, especially, if people haven't really had to deal with compartmentalization or thinking about airflow or an air leakage pathways. It's essentially thinking through all of the ways that water would be getting into your apartment. If you submerged it underwater, air is going to follow those same pathways. So we think it's just a good little thought exercise to sort of think about it and see how you can evaluate the various pathways of where air can be getting into an individual apartment. And so with that, the sort of place to start beyond, you've done your exterior wall or you're doing that well, is to start with the four corners of a unit. And again, we've picked a pretty easy example here. A nice square box. May not always be this easy, but I think for the sake of presentation here, it's a good way to just think about it. And really the key detail there that we've seen is running the drywall all the way to the back side of whatever your exterior makeup wall is. So in this case, it's CMU, or it could be a steel stud, and sealing the drywall at that location. So in the picture here on the right, you can see that the drywall is running all the way back to the CMU. It's being sealed at those edges. And on the left, you have one apartment. On the right, you have another apartment. So that is essentially blocking the communication of air from apartment A to apartment B. There's other things that come down the line that we need to focus on, but this is really sort of the first key critical detail, and we do have some good photos of this a little bit later. And then start thinking about some other, interior partitions, right? So we have an interior wall, we have maybe a little jog at where the door is. We have back-to-back tubs, so making sure we maintain our continuity there. Back-to-back toilets or bathrooms there. So continuing the exercise further down to think, kind of doing what we'll call a red line test and tracing the air barrier around, which in this case essentially is the drywall, to making sure we're maintaining our continuous air barrier. And so we've sealed, the corners, and I think I'll elaborate on this a little bit later, but you've sealed your corners, you've sort of maintained your interior air barrier continuity line, and then really these items here are sort of what's left, right? So there's always going to be some sort of holes in the drywall, and it's trying to minimize these as much as possible. So whether that's plumbing pipes coming through for a sink, or outlet boxes, or around doors, or around duct takeoff, these are all going to kind of contribute to the air leakage. But really the main, what I'll say, stopper of air is really trying to attack it first at the corners and doing the drywall detail. And then these are just kind of helping, tighten up the unit and squeeze it to its, kind of getting what's left. So the takeaway here, I think, is don't think if you're just doing these items, it's going to be an easy route, because now you're really going to be chasing your tail and try to have to hit every single thing that's penetrating through the drywall if we didn't get the sort of main, seals that we needed in the first place. So these are important, but again, I think this approach is really the first step, and then these are sort of not secondary, but sort of secondary in their effectiveness. They are still going to be needed, but you really need to do the bigger picture stuff first. And so a lot of this really starts, I think, in the design and getting it into the drawings and specs. So choosing details and specs that are specific, I think, is a good recommendation. We have some air sealing guides, which I have a link to at the end. But if anything, those can just be copied and pasted and put into a drawing set or an air sealing sheet. It's at least conveying the concepts and getting it, thought about and on the drawings. It's more work, but I think it's more beneficial if you show it specific to the project. So maybe you take a sample apartment and show the red line, show the critical corner details, and it just kind of clicks a little bit more if it's a project specific detail. But at least if you're putting in what we'll call sort of generic-ish details, at least you're getting those key concepts down on paper, and they're included right as part of the project requirements. Obviously indicating what the maximum allowed leakage is on the drawings or in the specs. It should be pretty straightforward, but just making sure that it's aligns with whatever program or code that you're following. So be specific on what materials to use. So in general, if it's 1/4 inch or less, you're using caulk or sealant. If it's a gap of 1/4 inch or more, use foam, but I say with some caution. So sometimes with the can spray foam, it can kind of get little, I'll call them ridges on the outside of it. So it doesn't actually fully air seal. So it can work. It's just making sure that you're applying it properly to making sure you get full heat adhesion all the way around of whatever you're sealing. Using appropriate sealants. So if it needs to be a high temperature caulk or low expanding foam, if you're using it around a window, or if you have it needs to be the red fire stopping caulk, just making sure that you're using the appropriate material for the appropriate situation. And then this one sounds kind of trivial, but it's actually kind of important. Cleaning out any gaps or cracks that you're about to seal, compressed air, vacuum, wipe it away. Sealants and foam to some extent, but more so sealants don't stick very well to, and especially tapes, if they don't stick very well to dusty surfaces, right? So you can apply the sealant perfectly and it may not stick if it's all full of drywall dust or just construction site dust. So it's sort of an important one there to make sure that whatever surface you're applying to is actually acceptable to be sealing against. And then consider what we're calling new, maybe not so new products. So there are high performance tapes that are out there that we've seen used for, say, taping windows, around windows, or if you're doing a sort of an interior air barrier membrane system. There's also aero barrier, which is a blown in sealant. So that's another approach that could be considered from an air sealing perspective. And so on site, there really needs to be someone that takes responsibility or is, quote, considered the air boss. They're the person that's on the job site, right, every day from the construction team, and they understand the details, they understand what needs to be done for compartmentalization, air sealing. You know, you might have a consultant or the architect or someone coming in and checking on the project periodically, right? But they're not there every day. So you really need a dedicated person that's staying on top of this stuff. And, you know, they may also be doing the exterior air barrier as in addition to the interior air barrier, what we'll call interior or compartmentalization. It could be separate, you know, sometimes there's one exterior super and then someone who's responsible for the, what we'll call the interior program, but just making sure that the GC is aware of this and that, you know, they do have the staffing, or at least it can be a supplement to someone's job to stay on top of this. And it's one of these things we like to say you'll be graded on it, right? So you do a blower door test and you get a number, you know if it worked or it didn't work, right? So it's not just a visual inspection, it's you're going to be testing this and seeing what the numbers are at the end. So yeah, we'll go through a little bit of a design exercise here, kind of pulling together those concepts that we just went through. So this is our apartment. It's a studio, which again, keeping it simple, but actually studios typically are harder just because the allowable leakage limits are lower. Not to say they're impossible, but you know, less wall area, less allowable as compared to say a 3-bedroom. And so like we said, we want to start on the exterior wall, making sure we have our wall and window installation all taken care of, focusing on the corners, in this case, the 4 corners, focusing on interior partitions, and then zeroing in on any of those final drywall penetrations. So kind of thinking about this in different ways. One is, you know, coming up the building. So on the left side here, we have a foundation wall to, you know, say an apartment on the first floor. So this is a below grade to above grade transition on the outside. And you can see picture on the right here is an example of that. So we have our below grade waterproofing and then what's going to be above grade waterproofing and air barrier. And, you know, it's properly overlapped and all the edges are sealed there. And then on the inside, right, this is typical, I think, for any floor, is if you have a self-leveling floor, commonly known as gypcrete, that when that gets poured in, it usually does a pretty good job of sealing from the floor to the bottom of the drywall, but it doesn't always seal it 100%. So I think it's something to just be aware of. You know, you hear the contractors a lot say, oh yeah, we're doing gypcrete, it'll be fine. You still have to sort of keep an eye out because it may not fully fill all areas, and then you have that gap at the bottom of the drywall to the floor. So if there's any areas that are left that the gypcrete didn't get, you know, it would be important to keep an eye on that and seal those to keep that bottom joint there continuous. Moving up the building, so this would be, say, middle of the wall or, you know, sort of any intermediate apartments. You have your air barrier on the outside. You may, you know, it depends on the design. You may have individual exhaust fans or individual ERV ducts. So those are penetrations through the wall. And we want to make sure those are obviously getting sealed from a water tightness, but also air sealing and compartmentalization aspect. And so we obviously would have some sealant or sealing detail on the outside and on the inside, whether it's masonry or CMU. It's a similar concept. And so this would be an example of that. On the left, you have 2 ducts here that are going to the outside, and you can kind of see here it's a little gray, but they're all sealed on the inside around the perimeter of where that duct boot is going through the wall. And then on the right side there, that's with the Phius system. So you can see that it's being sealed on the outside, and obviously that's the water management and air barrier from the outside. But we're sealing it on both sides, so we know that we're not going to get air movement through there. Moving up to the top of the building, so typically I have parapets, and this is wrapping the air barrier up and around the parapet and then down where it meets with the roof insulation. Again, these are, that sort of larger view of air sealing versus the sort of zoomed in view. But this is obviously important to make sure that your air barrier system's continuous and connects up with the roof, and you don't have sort of a unmitigated airway pathway at the parapets. And so what that looks like in person, the picture on the left, you can see the sheet membrane, the blue skin wrapping over the top, and the edge is sealed there. And then at the bottom there, they've had the fluid applied roofing is on, and then on the right side, you can see that now the roofing membrane is going in, and it's tying to that overlap of the blue skin and tying down to the liquid applied roofing. So it's a multi-step process in this case, and it can vary based on which systems are selected or how the parapet's being treated, but it's achieving the concept, right, is the main thing of keeping that air barrier continuous up and over, and then connecting to the roofing system. And then with windows, so the sort of typical or common approach is we wrap the rough opening with either sheet membrane or a fluid applied air barrier. On the left side, you can see that there's the blue sheet coming in, and the edges of that are all terminated. And then you see the window there with the clips, which aren't sealed yet. And then on the right, you can see the different project, but they've gone around and sealed around all of those clips and shims and sort of mounted the caulk on there. But that's really what you want to see. Sometimes projects would maybe only caulk between the clips, but then you actually can get some leakage behind them and around them. So we've found that really the best approach is just to fully embed them in sealant, so there's really no air leakage pathway between the window and the rough opening. So now that we've shown some examples of in practice the exterior, right? It's again going back to these four corner details and sealing those. So it's a similar concept. This is CMU, this is steel stud, but it's the same idea. I would be running that drywall to the backside of whatever the exterior wall system is, and getting it sealed at that joint. There should be pictures. I think they're a little bit later, so we'll get there. Working on the interior partitions. So, units aren't always perfectly rectangular, but it's, just again, thinking through that concept of maintaining the separation of the apartment. So in this case, we would want to continue the drywall around that walk-in closet there, which butts against a neighboring, it looks like, sink or maybe laundry room. And that's how we're maintaining that air barrier. So this comes down to some early conversations and sequencing to make sure that the drywall goes in the correct sequence. Question, do you find that air caulking window clips are necessary to achieve 0.3? So I would say that we've kind of just seen this now as a standard, and I would say if you're relying just on caulking between, could you probably still pass? Probably. If you're going to go for a higher performance project like passive house, probably not. So I would say, it's really just the best practice, and we honestly lately haven't seen it done another way, because we know this is just a belt and suspenders, more robust approach. So I would say you could. It'd be a little bit risky, and I would recommend just doing it. It's not that much more material. I mean, it looks like globs of caulk, but it may also be easier, right, rather than starting and stopping, and from each clip you're just going around everything and embedding it. So I would say you probably could pass, but it wouldn't be a strong recommendation to go that route. Okay. And so using tape like Sega, yeah, we've seen high performance tapes use that at interior window sealing, and it achieves great results. So, yeah. Think in 3D. So what we're conveying here is, right, we've done a lot of looking down at the plan, but now we want to think about, we have a 3D box, right, that we need to think about. So start thinking about some of these other connections. So we have our floor, which we talked about before, most projects are using a gypcrete or pour-in self-leveling floor, but just being careful that those joints are actually getting sealed. And then up at the top, thinking about what's happening up there. So we have most likely a poured concrete floor or precast concrete plank floors. And really what's key and critical is whatever's, the air sealing that's happening up at the ceiling to the floor plank joint. So if you have drop ceilings or soffits or things like that, a lot of, I'll say, bad stuff can happen up there if air sealing is sort of an afterthought. So it's really making sure that that drywall is hitting the underside of the plank or a concrete floor and getting sealed up there. And then whatever is happening below that in the drop soffit or whatever you have is, not that much big of a deal. Whereas we've seen this sort of get neglected. You look up in a drop ceiling and you just see drywalls that's short or a bunch of wires and pipes going through, which is, essentially going through your primary air barrier location. So thinking really the joint between the actual floor above and the drywall that should be meeting it is the barrier, and not whatever, maybe a drop ceiling or soffit or whatever you have that's, quote, hanging down lower as being the barrier. Similar to before with some fire stopping stuff, but if we have, obviously we're gonna have pipes going through for plumbing. So this is looking up from the bottom side, and you can see that it's stuffed with the mineral wool. And if you went up a floor and look from the top, you should see that it's well fire stopped. Most projects don't do top and bottom unless they're required to seal the bottom based on whatever fire stopping system they're using. But in this case, it's usually just top. So you can see, looking up at stuff, you should see it sealed on the top and then sort of out of view. But these two pieces of sheetrock are also sealed to the ceiling. It's shown on the diagram, but not easily seen in this picture. Another question, we see gypcrete held off walls to prevent drywall getting wet. Do you think it's important to seal GWB to floor after gypcrete? Yeah, I think it is. And, that it's kind of going back to that concept of, we are quote sealing the four corners, but there's no way to get that ever 100%. So there's always going to be air movement in those walls. And if you think about the linear footage, right, of the bottom of flooring or flooring to drywall connection, it's going to be a lot of linear feet, even if it's a small gap. It's so many linear feet that could really destroy your blower door number. So it is a sort of critical piece to air seal. And then getting back to our final air sealing. So this could be around doors. You can see the lower one in the middle. All the sealing is done before any drop soffits, and medicine cabinets can also be tricky if they're recessed, but making sure there's a piece of drywall back there and it's all taped and sealed before the cabinet goes in. So these are what we'll call the quote last minute items. In ICF exterior walls, does the drywall need to go to the concrete core, removing the insulation layer, or can it be sealed to the inner layer of ICF foam? So we've seen ICF where the ICF blocks are obviously just stacked, and then the drywall goes right into it. There's the sort of plastic furring that's built into that system. And we don't, the insulation layer is not removed. The intent of the ICF, right, is that you have the foam on both sides. It's acting as the form, and then it's also, after you pour, you have the benefit of the insulation on both sides. So it would sort of take away from that system if the insulation was removed. The ICF gets set, the concrete gets poured in, and then the drywall goes right up against it, and there's just, there's these sort of black plastic panel or ribs, I guess is the right term for them, that the drywall just gets it screwed into. And so with these various concepts, right, it's important to get it back into the, before we go down this whole road, it's important to get it into the drawings. And so this is a pretty simple example, but we have our exterior air barrier system shown, and then we have our compartmentalization air sealing shown, just sort of at a high level, some general notes of what systems are being used and how it's going to be implemented. And then again, like we said, putting in specific details. We have our guides where you can sort of take those and adopt them and put them onto on the drawings, or sort of make a hybrid of our stuff and your own stuff. But again, it's just really getting the concepts into the drawings. And so here's what a air sealing details sheet might look like. And so you have your typical full building on the lower left, which we've gone over. They've shown an apartment there, and then all of the various, intersecting joints and pipes and things like that. So some is text, some is pictures. It really depends on, I think, the designer's way of conveying the information, but it is good to have this air sealing detail sheet, so it's known that this is important. It's a page in the drawing set, and project teams have an eye out for this. So evaluate air sealing during construction. So a sort of typical process would be, this is sort of bare bones, I would say, but at a minimum, a pre-drywall inspection. So this is essentially just visual, walking with the contractor and the installers, kind of making sure they're on track, trying to catch any big items before the apartment's too far along. You usually can't necessarily do any tests at this point because the drywall isn't really finished, so you wouldn't be able to build up any pressure. But you can kind of know what you're looking at, excuse me, get the key details and kind of make sure they're on track for the project. And then obviously at the end, you have your testing, the blower door, you know, it's going to see what the final numbers are. And with that though, we do recommend or push for a mock-up apartment to be completed earlier or sooner than the others. So you can, you know, test that one earlier and see if there's any sort of last minute issues that need to be addressed before it gets too far along. So that might fall somewhere in between these two phases. And so this is an example of what would a pre-drywall look like. So the image all the way on the left, you can see you're seeing the red fire stopping at the top of the wall and then down around at the side of the wall. At the middle one, again, a similar concept. You can see the red fire caulking on the right, and you can see the sheetrock going all the way to the ceiling before that drop ceiling or soffits in the way there. So making sure they're sealed up above there and not relying on the ceiling below. And then the, you know, this is an example of just sealing an outlet with, they're using, happen to use mastic, but a lot of times you see the putty pads or fire stopping products there. So these are just some things you might see or be looking for at a pre-drywall inspection. I mean, there's obviously a lot more, so we do recommend using checklists. So whether that's, you know, straight from the energy code, from Energy Star, from LEED. So these are reminders, right, of all the spots to be looking at and trying, you know, in kind of keeping it looked at in a systematic way. So this could be used by the air boss or whoever's on site. Maybe they fill one out per apartment, something like that. You know, you don't want to go overboard, but or at least have them thinking about this stuff and keeping it in mind. So that, you know, just so it doesn't feel overwhelming. It's a way to organize and kind of think through all this stuff. So it's a good way for the people on site and anyone that's, you know, reviewing this stuff on site as well. A third party as a way to make sure we're checking these things and, you know, not accidentally forgetting about important areas. So this was I alluded to a little bit before, but preliminary mock-up lower door tests always recommended. And then this is, you know, working with the team, seeing if they can get one apartment pushed further along. Maybe it's a model apartment or one that's, you know, on a floor that's a little bit further that they can, you know, just send a couple extra guys in there to finish. So, you know, at a minimum, you want your drywall installed, all the seams taped. Maybe you don't have outlet covers on yet, or, you know, some last minute stuff like that, but it's still kind of good enough to build pressure and get a number and see where it's at. So this is a pretty strong recommendation, and most projects do follow up and do it because they want to know as well, how are we doing, right? We don't want to get all the way to the end and then find out we have issues. So it's you know, it's embraced by most teams to do a mock-up or a preliminary test as soon as they can. And finding air leaks during testing. So what to say, intuition, just what you know about air leaks or where they could possibly happen, right? If you have a drop ceiling, that's probably one of the first places you probably would go look to see if stuff up there is unsealed. And, you know, thinking about the air leakage pathways of that particular apartment. Sound, if you hear a lot of whistling, that's an indication of an air leak. So maybe it's something as simple as, window isn't fully closed, or there's just a piece of sheetrock that got knocked out somewhere and you hear audible noise. That could be a way to detect air leaks. Feeling around with your hands, that's a great benefit of the blower door. And that, it helps you really understand where leaks are coming from, and also, if there's doubt amongst the installers, like, oh, no, we seal this, but you can show them, or they feel air. Those are, hey, we're getting air leaks somewhere, right? So I have to kind of figure out where it's coming from. And related to that is theatrical fog. Hand fogger or party fogger works just fine. And you can use IR, but you do need some infrared, but you do need some basic training and kind of know what you're doing. And, so you have the right temperature difference and really kind of understand what you're looking at with those images. So it doesn't really need to be a complex solution to finding air leaks. It's thinking through, the processes of all the steps of air sealing, where could they potentially missed, and more times than not, it's feeling around with your hands and finding where the air leaks are coming from. And then corrective measures. So this, hopefully we've done most things right and we're sealing in all of the right locations. And it's, say a prelim test and it's a little bit high, but maybe they didn't seal the plumbing penetrations through the wall, or maybe they didn't seal the gap at the sheetrock to ductwork. So again, we want to try to catch this stuff before we get too far down the road, and it's basically a finished apartment and now we're running around trying to find air leaks. So again, that's why we're thinking about this up front, getting it in the drawings, having the air boss on site, having that pre-drywall or several pre-dry walkthroughs, doing the preliminary tests. So these are all sort of steps along the way to hopefully avoid having these issues at the end. Question, do you find smoke fire safing sealants are sufficient, or should architectural caulking such as EcoSeal be used? Smoke and fire safing sealants can be sufficient, but you really need to look at them. So, if you kind of just glance up and see the bottom of a pipe is sealed, and that may pass for fire inspection, really what you need to do is get up on a ladder and check the top of it, right? And see that the whole area is sealed and fully adhered to the wall. So it's not relying on it 100% because it is fire stopping, and not to knock whoever's checking fire stopping stuff. But I would say that you have to approach it differently in terms of thinking about, is this actually holding air for for our test? So yeah, I would say it can work and it does work. It just needs to be checked thoroughly from an air sealing perspective to make sure it's going to do its job. Can air barrier be used in a finished apartment if it fails the blower door test? Yes, it can, but there's a lot of prep work that goes into air barrier. So it's essentially injecting in a sealant, a particleized sealant into the air, and then that's going to, catch all the gaps and cracks that are left and remaining. So, but if it's totally finished, you need to protect the cabinets, you need to protect the floors. So there is a good amount of prep work that goes into that. So you'd have to figure that into the timeline and budget and all that fun stuff. Who's doing the prep work? Are they doing the prep work? Is the contractor doing the prep work? So it can be, but don't think it's just, oh, they show up and seal all these apartments and think you're going to be fine, whereas it's a little bit more involved. Does a steel door need weather stripping on the hollow metal frame entry door? Yeah, I would say essentially, so I'm assuming this is for an apartment entry door. You do need weather stripping to begin with, but I'm pretty sure it's ANSI or Phius. One of them essentially says you need weather stripping on that front door. And if it's an exterior door that you're asking, I would say definitely need it on all exterior doors, weather stripping and bottom sweep. So for the last bit here, we're just going to go through some various examples of what I'm calling good and bad. There's no particular order here, but it's just things we've seen and stuff to keep an eye on. So on the left, you can see that there's some insulation boards up, but all sort of raw dense glass, and it hasn't been sealed at all. So that's obviously a big red flag that insulation is going on and covering up just raw exterior sheeting. So that's a big problem. That's even beyond air sealing. That's going to be a real disaster for water management. So, really talking to the construction team, having them understand the importance of all of your exterior air barrier and waterproofing systems before any of your exterior insulation starts. The image on the right here, this is an older one, but this is a fluid applied air barrier, and the installer was using a notched trowel to apply it to the wall, which kind of defeats the purpose, right? So each time they were scraping it on, all of the notches in the trowel were, scraping off the amount that they needed. So I think it's really just educating installers if they're, not familiar. I'm hoping most have at least a basic understanding, but, looking through the manufacturer's data sheet, having them understand that it needs to go on a consistent, flat, even thickness throughout. Does it take 2 coats or 3 coats to get that? And, really sort of educating installers as much or as little as they need to make sure the installation is going to be the right way. This is an example of just a transition between poured concrete and the CME block. Obviously a joint there, which is an air leak problem, but again, I think water is first, and that could be a real problem for water management. And then on the right, that's the remediation of fixing that joint. Here's some examples of fire stopping. Again, as long as you're getting it installed correctly and all the way around whatever you're trying to seal, it should be doing its job. And again, if there's things up high or sort of hidden in corners, it's really checking around it 360 degrees to make sure that it's being sealed on all sides. This is an example of an abandoned penetration. So it looks like they, cored some holes for plumbing risers, maybe not in the right location, and then I had to move them. So now this is just a hole in the floor, which is now connected to a wall cavity, which is now going to come out where your outlets are and your switches, and maybe have recessed lights. So thinking about these things and making sure these get filled in or sealed in some way before they get fully enclosed. And in a similar vein, this is, electrical conduits that happen to have an extra one or abandoned one. So just plugging that up to prevent that air leakage pathway, which gets into the wall cavity and then is eventually going to make its way out somewhere where we have, a hole more or less in our sheetrock for, cable, wire, outlet switch, things like that. These are some of the putty pads or putty packs, and you can see they're not really installed that well. Each manufacturer has their own sort of guidelines on how this goes, but it's essentially wrapping the entire back of the box and should be meeting up with the drywall. And so by just kind of slapping them on, it's really not doing what we need them to do from an air sealing perspective. And then the one on the right is a more thorough example of how that box is just fully sealed. These are some pretty bad examples of fire stopping. So the one up on the left is going to be pretty sure up in a drop ceiling, and you can see it's just that the sheetrock is short. It's not meeting the top of the wall. There's a gap between the boards there. And obviously this is not great from a fire perspective by any means, but it also is going to be impacting us from an air sealing perspective as well. And you can see the bundles of wires kind of out of frame there, but seeing where those are going, if those are passing through the drywall, making sure the best way to do it is to run one wire on its own and then seal all the way around it. Doesn't always happen, so then you have this bundle of wires, and it's not ideal. You can seal around the bundle, but you can never actually really seal in between the bundle. So you're sort of doing the best you can with bundles of wires, but yeah. The one on the right looks like they tried. There's some red stuff there smeared around, but obviously, there's a gap there. They probably had to remove drywall to get in there to do something, right? And then kind of just put it back. But I would kind of go back to my earlier comment of don't rely on fire stopping 100%. Kind of take it with a grain of salt, and you have to look at it a little bit further to make sure it's actually doing what it's intended to do, and having that overlap with the air sealing side of it as well. So this is an example of what we'll call good. So you can see all the fire stopping at the top is done. Looks pretty good, and probably done before the framing was in, or in this case they could probably work around it. But if that was all at the top of the wall there was just kind of left short, now we have this big open pathway up into this open ceiling plenum cavity here. So it's important to make sure we're getting these things right at the right stage of construction, because after that, this is the bathroom ceiling is installed. Trying to go back in there and to seal this is going to be sort of a nightmare. You have to cut holes and try to reach in these corners, whereas if it's done properly first and then the framing is added after, it's just a much easier approach. You can also see the wires that go through in these cases happen to be single, which is nice, and then those are sealed all the way around as well. And then a little bit hard to make out, but they have a piece of sheetrock coming down at the tub area as well, and that's sealed to the outside. So they're maintaining their air barrier connection all the way around. So in this one, the picture on the right, it shows the drywall run all the way to the exterior wall there. It isn't sealed yet, but at least it was sequenced properly to have the drywall there first. The space in the stud framing was thought about, so you can slip that piece dry and slip that piece by and get it to the outside. and it does look fairly accessible, so they can come in and seal that. And then the picture on the left, similar to before, the caulking at the top, and then they're doing their pipe insulation, fire stopping. Again, you're seeing it just from the bottom, but hopefully if you go to the floor above, you would see the caulking around those pipes on the top side as your air leakage pathway barrier there. A couple more of these. On the right, you can see that it's run first and still accessible, so they can seal it. The one on the left is already complete and caulked. So it's not, I don't want to say it's not difficult. I think it just takes some thought and planning and understanding of the whole team, but obviously the installers and the general contractor to get this stuff sorted out so they can plan accordingly and really kind of work from that outside in approach, more or less, to getting these details implemented. And then, you know, moving inwards, we have plumbing penetrations, you know, sort of our last push. So unsealed toilet penetrations, that can be pretty easy, just sealing there. Around maybe a drain line, you can use foam, but make sure you get it all the way around. Around the shower head is another one. You know, again, it's sort of last minute air leakage that we're pushing to get, and sort of maintain that drywall, more or less, air barrier. Some more plumbing penetrations. If you're using, in this example, if you're using foam, maybe a little bit overkill, maybe you have to trim it back, or maybe if you use a foam gun, you can kind of dial it down, the amount of foam that's coming out. Or if it's going to be under a vanity, maybe it's all right, it's sort of out of sight, but it's sort of, might be silly, but it's also another consideration that you may not want to have these big blobs of foam there. So it depends on how big the gap is. I'm pretty sure they use foam here because the gaps were big, but most projects would end up using some sort of sealant to seal around these pipes. Another big one is around door trim. So this should really be covered under the painter's scope, more or less. And these are some pretty bad examples of the you know, interior door frame to drywall, just sort of left pretty rough. And you are going to feel air around these. Most times they do get the sides pretty well, but the tops may be missed just because they think no one's going to look up there. And if you're, you know, air sealing or you're inspecting an apartment, that's another spot you know to look, is the top of the door. Maybe they got the two sides but not the top. And then the other idea here is the interior of closets. You know, again, it's an area that I think all people won't even see. It's not a big deal, but if it's sort of left raw, that's, you know, a gap between the drywall and the frame of the door here. So those are some other areas that we would commonly find to be potential air leak locations. So just a heads up on those. Air sealing and bad, these are bad. So this is at a window stool, kind of the underneath joint of it. So this is where the stool sort of juts out and meets with the drywall. Again, a painter and caulking detail. The one on the right is just sort of a rough, unfinished apartment. The one on the left maybe thinks, oh, if you're looking down at this, that you won't really see it. Don't worry about it. But it'll be, you know, it's a small crack, but it's can be a lot of linear feet of leakage. So I would say that this is another one to look. You know, a lot of these areas are, you either have to get up on a ladder to look or kind of bend down into your knees and look at. So that's, I would say, where a lot of the problem area is. potentially could be. And the bottom one here is the gap between the window frame and drywall. So again, just a caulking thing that should be covered with by the painter that gets sealed, and that's your connection between the exterior there and the interior drywall. Just a couple others here. So we have on the left a telecom box, which those are usually notoriously pretty leaky. They have a lot of holes in them for whatever reason from the manufacturer. So really the best we've seen on those is the drywalls run tight to the box. It's sealed at that location, and then you have your cover that goes on, the door closes, and the cover gets sealed to the drywall. It's sort of hit or miss on how leaky or tight those are. Unfortunately, we've had a project where they actually wanted to tape inside all those holes, but you should really, if you're going to do that, get approval from Verizon or whoever is giving you that box to make sure that that's okay. But yeah, this is one of those things where you just kind of live with the leakage because the box itself is leaky and it's from a telecom company, and they may not want you to alter it. And access panels. So sometimes these are a little bit big, or I think just in general, you can add extra weather stripping on the inside of the door to make sure that when they close, they're airtight, or I don't want to say they'll be airtight, but they'll be tighter than if you didn't have any extra gasketing. And these are just some examples at floors. You know, a lot of times the trim does get caulked top and bottom. But if it's missed, or if you have maybe, this is an older project, but like a baseboard enclosure where it's just sort of the drywall meeting the floor, on the lower right there, it's just making sure that those areas get sealed. And then this was about exterior doors. So yeah, these are exterior, like to the outside, not to the from the apartment, but clearly missing bottom sweep is a problem. Missing perimeter weather stripping is a problem. So on these, we recommend on the bottom a brush, or sorry, not a brush, a solid door sweep, just because the brush can kind of easily let air through. And then on the perimeter, mechanically fastened. So a lot of times there's the peel and stick gaskets, but they sort of fail over time and fall off. Whereas the mechanically fastened ones are screwed into the frame and are pretty robust. So I'll just get to the recap here and then try to get to these last couple questions. So understanding the why, how and where, why are we air sealing, all the benefits beyond, right, just energy, whether it's sound, smells, knocking down the stack effect, comfort, so, or your program that you're participating in. So it kind of lays the foundation of you know, what's the point of the compartmentalization air sealing, how we're doing it, right? We're hopefully getting a lot of those details into the drawings and getting them on the radar of the contractor, having them really take ownership of it with support from others as necessary. And the where, right, the critical locations, the exterior wall, the interior demising walls between the units, interior partitions, and then sort of what we'll call what's left. Knowing how much you need to do to get to your limits. You know, the 0.3 isn't necessarily, I don't want to say it's easy, but I don't want to say it's super hard. It's reasonable and it's doable as long as you do the right things. So keeping that in mind. Talked about detail and specify, getting it into the drawings, inspect and test, you know, progress checks along the way, and getting that unit as early as possible for the blower door mock-up tests. A lot of communication throughout, right? Discussing how these details are going to get installed. talking them through on site and conveying these concepts to the people who are essentially building them, and hopefully have a successful blower door test or testing at the end of your project. These are our air sealing guides. They're on our website. You can download them. They're widely available. Use them however you like, put them in your drawings, all that fun stuff. That's my contact info. And I'll try to get to these last couple of questions here. Follow-up question on sealants. The fire-safe material is meant to expand and seal during fire heat, so I understood it not to be the best sealant. I'm seeing your examples using it almost exclusively. It sounds like you're successful in meeting compartmentalization this way, correct? So yeah, the fire-stopping materials, they're called intumescent materials, and they do expand when they are exposed to fire, but that doesn't mean they're not being applied in a way that they're not actually stopping the air movement now. So you could see in a lot of the pictures that we showed, whatever is being sealed in these examples would be around pipes. They are fully sealing around those, right, with this red, what we'll call red fire stopping sealant. There are other fire stopping products we're not so crazy about. There's fire stopping sleeves where the pipe can kind of run through this sleeve that has an intumescent around it, and they're not always sized appropriately. So in a fire, it would expand and kind of seal around the pipe, but it's not stopping air. So we really wouldn't recommend or want that from an air sealing perspective. Also, there's fire stopping like pillows or blankets, which you really would see maybe shoved in around a duct or something like that. And it's a similar concept, right? Where, it will expand because of the intumescent and fire stopping materials, but it's not going to stop air now from an air sealing perspective. So that's another fire stopping product we would not recommend and really stay away from. So I think don't rely on fire stopping solely. You would have to understand what the approach is going to be and what the system is that they're using to achieve their fire stopping, to make sure it also actually overlaps with air sealing and is going to air seal now and not only expand during fire stopping. Just a comment, I think we like to seal the stud bay that houses the Verizon box to give it access to that much volume, but not the hole behind the wall volume. Yeah, that's a good point. I think in our scenario, it might depend where that box is located and, if they have space and area and framing to do that. I think the projects that we've seen, and again, these are sort of, CMU and steel, so we're not honestly up against a lot of the challenges that are in wood frame stuff, which my colleague Steve Klecki presented on, is, we just sort of take what we'll call the hit from these and know that we're going to be all right. But I think it's good to think about other ideas about how we can actually address these, because it does seem unfair that you're just getting this box from the manufacturer and it's Swiss cheese, right? So now you have to go out of your way to box around it or plan accordingly, whereas they should just be giving you a tighter box. I think it might be for heat dissipation from the, if you have a modem or something, but it just seems like it's working against you right off the bat.
Hi, Mike. It's Anna. It looks like we don't have any more questions, so I think we can wrap it up here. Thank you for this great presentation. And yeah, it's 1:30. Just a quick reminder that this is AIA and BPI approved. So for anyone in the audience that does want to get the CEUs, I will be sending out a survey specifically to collect everyone's IDs and information. But yeah, I think we can call it. It's 1:30, and yeah, thanks again, Mike, and thank you to the sponsors of Energize Connecticut. Yeah, we can end it here. Have a great day, everyone.
All right. Thank you.
Thank you. Bye.
Bye.